আমরা পড়ছিলাম এসটিপি প্রোটেকশন। কি কি প্রোটেকশনের আমাদের প্রসেস ছিল, টুল ছিল? রুট গার্ড, লুপ গার্ড, বিপিডিউ গার্ড, বিপিডিউ ফিল্টার আর ইউডিএলডি। এদের মধ্যে আমাদের হয়েছে কোনটা? ইউডিএলডি, তাই তো? আমাদের ইউডিএলডি হয়েছে। ওকে, শুনতে পাচ্ছ?
হ্যাঁ স্যার।
ওকে ওকে ওকে, ঠিক আছে। চলো আজকে আমরা আরম্ভ করব রুট গার্ড দিয়ে। হোয়াট ইজ রুট গার্ড ইন এসটিপি? সো ফার্স্টে আমি ধরে নিই আমার একটা এক্সিস্টিং টোপোলজি আছে। দিস ইজ মাই এক্সিস্টিং টোপোলজি। So this is switch 1, this is switch 2, this is switch 3, this is my root bridge. This is fast Ethernet 0 by 1. This is fast Ethernet 0 by 2. This is fast Ethernet 0 by 1. This is fast Ethernet 0 by 2. This is fast Ethernet 0 by 1. And this is fast Ethernet 0 by 2. This is my existing topology. So these two port will be DP. This is root port for switch 2. This is root port for switch 3. This is DP. And this is AP. Suppose we have two LAN user, one in switch 2 and one is switch 1. This is user 1 in switch 1. And this is user 2 in switch 2. So they are communicating with each other via this path. Actually they are communicating this path. Okay? এবার ধরো আমি বাইরে থেকে একটা সুইচ ইন্ট্রোডিউস করলাম। which has a lower bridge ID. Priority will be 32768, but base MAC address is lower than all other switches. Okay, so it is an external switch. এবার এই সুইচটাকে আমি ট্রাঙ্ক লিঙ্ক দিয়ে সুইচ 3 এর সঙ্গে কানেক্ট করলাম। So suppose it is FA 0/3 and it is FA 0/1. So now this external switch claiming itself as root switch, this external switch now claiming itself as root switch. Now switch 3 receives superior BP2 from this external switch. Switch 3 receives superior BP2 from this external switch, and this external switch becomes a root switch of this topology. Okay? And the entire topology will get changed. Okay? Now this port become root port of switch 3. Okay? These two port become designated port of switch 3. Okay? It will become root port for switch 1. It will become root port for switch 2. It will become DP, and this port will become alternate port. So now these two LAN user will communicate with each other via this path. Okay? Because the port of first Ethernet 0/1 port of switch 2 becomes alternate port. It neither send data or any other kind of frames. Now the port first Ethernet 0/1 of switch 3 will take 30 seconds to be in forwarding state. Actually it is already in blocking state. Actually it is already in our existing topology. It is already in blocking state because it is alternate port. So from alternate port to become DP, it will take 30 seconds listening and learning. 15 seconds each. So there is an outage of about 30 seconds between these two LAN user when the new external switch is introduced in this topology. Okay? Suppose the external switch is intentionally removed from this topology. Again the entire topology will change. Again this port become alternate port. Again it will take 30 seconds. Again switch 1 becomes root bridge. It will become root port. It will become root port. and to become root port it will take 30 seconds because it is already in blocking state, as it is an alternate port for this topology. Okay. Again the LAN user will face an outage of 30 seconds. Okay. Again these two LAN user will face an outage of 30 seconds. Clear? Any doubt up to this point?
No, sir.
So now we have a solution that is known as root guard. Root guard is a solution that protects our root bridge in our existing topology. Okay. It is used to protect the actual root bridge. It is used to protect the actual, or you can say original, root bridge. Okay. Root guard feature is enabled always in DP. Where it will be enabled? Root guard feature is always enabled on DP. DP stands for designated port. So in our existing topology, we will enable root guard feature on this port. So what will happen if we enable root guard feature? Now when the external switch connects with switch 3, sends superior BPDU, switch 3 will forward this superior BPDU to switch 1 and switch 2 both. And when a port receives a superior BPDU, while root guard feature is enabled on that port, when a switch receives a superior BPDU on its designated port while root guard feature is enabled on that designated port, the switch will put that port on root inconsistent state. In which state? Root inconsistent state. Okay. It is a type of state. It is a type of blocking state. It is a type of blocking state. Actually, switch puts those ports, those designated ports where root guard feature is enabled and a new superior BPDU is received in error disabled state. In error disabled state. So what will happen? Both switch 1 and switch 2 will not process those BPDUs, those superior BPDUs which are coming from switch 3. Clear? So, though this external switch becomes root switch for switch 3, but not for switch 1 and switch 2. This part of our topology is still protected. Okay? So if there is a LAN user in switch 3, if there is a LAN, already there is a LAN user in switch 3, neither user 1 nor user 2 will communicate with that LAN user. Clear? Because these two ports are in blocking state, root inconsistent state. Okay. So once the attacker removes this external switch, these two ports automatically becomes DP after 20 seconds. Okay, after 20 seconds. Clear? Mind it, we will never configure root guard feature on root port, because root port is always received BP dues. Root port is always received superior BP dues. So we will never configure root guard feature on root port. Clear? So let's go for a practical. So this is our topology. Take some time.
এখনো হয়নি।
No. So in switch 1 we need just these two ports. So interface range giga Ethernet 0 by 1 giga Ethernet 0 by 3 giga Ethernet
Hmm.
1 by 0 hyphen 3 shut.
Hmm.
In switch 2 we need these two ports only. Interface range giga Ethernet 0 by 2 hyphen 3 giga Ethernet 1 by 0 hyphen 3 shut. In switch 3 we need interface range giga Ethernet 0 by 3
Hmm.
giga Ethernet 1 by 0 hyphen 3 shut. And in switch port initially I will shut down all the ports. Okay,
Hmm.
giga Ethernet 0 by 0 to 3 giga Ethernet 1 by 0 to 3 shut. So initially this is our existing topology. This is our existing topology. Okay,
Hmm.
so show spanning tree. So I'll make switch 1 as root bridge. Spanning tree VLAN 1 priority 4096. It will become root bridge. Show spanning tree. This bridge is the root
Hmm.
and show spanning tree. And show spanning tree. I'll make switch 2 spanning tree VLAN 1 priority 8192. So as per our diagram, this is root bridge, this is root port, this is root port, this is alternate port, and sorry, this is DP, this is alternate port, and these two ports of switch 1 is designated port. Okay, so let's check. Show spanning tree. Switch 1, both are, this is the root bridge. Switch 2, show spanning tree. Switch 3, show spanning tree. G0 by 1 and G0 by 2. This is alternate port and this is root port. So clear? It is still in learning state, switch 1. It is still in learning state. Now it is forwarding state. Now I introduce this switch 4 as root bridge for this topology. How? I will change the it gets down. So this is our existing topology. Is it clear? Okay. Now give me some time to get switch 4 up. Enable configure terminal, hostname switch 4. interface range Giga Ethernet 0 by 0 to 3 and Giga Ethernet 1 by 0 to 3 sharp. So in our this existing topology, switch 1 is root bridge. Now I will make root bridge switch 4. How? Spanning tree, VLAN 1, priority 0. Okay? But this switch is still not connected with this topology. Okay? So switch 1 is still root bridge. Now I will enable this interface. Configure terminal, interface Giga Ethernet 0 by 0, no shut. Okay? Now this switch will send superior BPDU to switch 3 having priority 0. Okay? And eventually it will become the root bridge for this entire topology. Clear? This port will become root port, this port and this port will become root port. It will become DP, it will become alternate port, and these two ports become DP. So let's check. No shutdown. Show spanning tree. So switch 1 is no more. Switch 1 is no more root switch, okay? Switch 4 is now show spanning tree. This bridge is a root. And see show spanning tree in switch 3. This is in learning state Z0 by 1. It will take 30 seconds, okay? So our entire topology gets changed, okay? This is still in learning state. Now it is in forwarding state, okay? So again I disable the interface of switch 4. Interface Giga Ethernet 0 by 0 shutdown. So it will stop sending BPDUs. Now it will become root switch. It takes some time. Switch 1 again become root switch. So this bridge is a root bridge. Okay? So now I enable root guard feature on DP. So in GI 0 by 0, GI 0 by 2 and GI 0 by 1 of switch 2. Okay. So let's check. It is in listening state, it is in forwarding state. Okay. So in switch 1, configure terminal, interface range, Giga Ethernet 0 by 0, Giga Ethernet, interface range 0 by 2, spanning tree, guard root. Because these two ports are designated port, so root guard is enabled on Z0 by 0 and root guard is enabled on Z0 by 2. And in switch 2, configure terminal, interface, Giga Ethernet 0 by 1, spanning tree, guard root. So let's start debug spanning tree events. Debug spanning tree events. So I will enable this port again. No shut. In switch 4, it will send superior BP2. BP2 is received by switch 3. Switch 3, for switch 3, it will become the root switch. Switch 3 makes these two ports DP. It will send superior BP2 from these two ports. Once this G0 by 2 and G0 by 1 of switch 1 and switch 2 respectively receive superior BP2s from Z0 by 2 and Z0 by 1, it will make these two port root inconsistent state. Let's check. In switch 1, root guard blocking Z0 by 2 in switch 1. Root guard blocking Z0 by 1 in switch 2. Okay? So let's check in switch 1. Show spanning tree. It is still root bridge. Okay? And this is root inconsistent state. Clear? It is blocking state. In switch 2, show spanning tree, blocking the root inconsistent state, and for switch 2, the root switch is still switch 1. Root port is Z0 by 0. Okay? But in case of switch 3, show spanning tree, root port is on Z0 by 0. That is for switch 3, root bridge is switch 4. Okay? G0 by 0 become root port. Okay? Clear? So these two ports are now in blocking state. Once BP2 switch 4 stops sending superior BP2, it will become automatically in forwarding state. So let's check. Shut down. So it is in blocking state already. This port and this port are still in blocking state. How long it will be in blocking state?
Hmm.
20 seconds to suppress the to express the previous received superior BPD and then listening and then learning. Okay.
Hmm.
So now it is in listening state. And it will be 32 when it is on forwarding learning state. Yes, 32 is learning state. So already, and it will be on 47 in forwarding state. So it takes 50 seconds to recover. Okay.
Hmm.
The ports which go to root inconsistent state will take 50 seconds to recover.
Hmm.
See, it is in 47 forwarding state. Okay, clear?
Hmm. Hmm.